Hello students, this question is based on the Thevenin theorem. In this theorem, you have to find out the Thevenin equivalent circuit of this shaded area and then find out the current in this load resistance for the values 2 ohm, 10 ohm and the 100 ohm. So let's do the solution for this. Solution. Step number 1. First, find out the Thevenin voltage for this shaded area. Find out the Thevenin voltage. And what is the Thevenin voltage? You know, in the previous lecture, it is nothing. It is the open circuit voltage when the load is removed from the circuit. If the load is removed from the circuit, then circuit becomes the circuit this is R1 and this is R2 and this terminal is open. So this A and this B and this is open. The voltage appeared across these two terminals is known as the open circuit voltage or Thevenin voltage. And here this is E1, this is plus and this is, and the value of this 9 volt, it is R1 is 3 ohm and R2 6 ohm. Let's find out the voltage across these two terminals. Apply KVL in this closed loop. Suppose the current into this loop is I, then KVL may be can be written for this loop E1 is equal to I R1 plus R2, and the value of the I from this equation will be E1 upon R1 plus R2. Now the voltage across this, suppose this is the point capital A and this point is capital B. If I found the voltage across these two terminals, then it will be EAB is equal to I into R2, and the value of the I from this equation, suppose this is equation number 1, then EAB will be E1 R2 divided by R1 plus R2. Because here there is no resistance here in this path, that means there is no voltage drop from this to this. Hence small a point and this capital A point are at the same potential. That means EAB is equal to EAB, and this voltage also known as the open circuit voltage, that is EOC, or we can write it ETH, that is Thevenin voltage, and it will be E1 R2 divided by R1 plus R2. Now substitute the value of the E1 R2, that means ETH will be E1 is 9 volt and R2 is 6 ohm, R1 is 3 ohm plus 6 ohm, it will be 9 6 is 54 divided by 3 6 6 3 plus 6 is 9, and 9 divide this, 9 1 is 1, 9 6 is 54. That means ETH is equal to 6 volt. Now next step is to find out the Thevenin resistance. Step number 2, find out the Thevenin resistance or short circuit resistance. In order to find out this resistance, you have to remove the voltage source from the circuit, and if there is any current source, then remove and then open that path in which the current source is connected. So in this case there is no current source here, there is only one voltage source, and now remove this voltage source from the circuit, and this is R1, this is R2, and this is terminal number A, and this is terminal B, and now this voltage source is removed from this circuit and it is short circuited. That means it's short circuit. That means the resistance in this path is 0. If there is any internal resistance present in the circuit, then remove the voltage source with their internal resistance. So here there is no internal resistance. Now the resistance appeared here is on Thevenin resistance, and the value is given by, that is RTH is equal to, these two resistance are in the parallel, because suppose the current flowing from this this A to this, then these two resistance will be in the parallel, that RTH will be R1 dot R2 and R1 plus R2. Put the value of the R1 and R2, that is RTH will be, R1 is 3 into 6 divided by 3 plus 6, that is 18 divided by 9, and it will be 2 ohm. So here RTH is equal to 2 ohm. Now make a Thevenin equivalent circuit. Thevenin equivalent circuit, which is given by, here there is a voltage source which is ETH, and there is a resistance which is Thevenin resistance RTH, and this is terminal number A, this is terminal B, and here load is connected, and this is variable resistance. Now we have to find out the current into this load resistance for the different value of the RL. Let us assume the current into this load resistance is IL. Find out the current IL into the circuit, then apply the KVL. ETH is equal to IL RTH plus RL, and the value of the IL will be, IL is equal to ETH divided by RTH plus RL. Now substitute the value of this ETH, and we have calculated the value of the ETH 6 volt and RTH is 2 ohm. So that means it is 6 volt and it is 2 ohm, and IL is 6 divided by 2 plus RL. Now for different value of RL, calculate the IL. If RL is equal to 2 ohm, IL will be 6 by 2 plus 2, that is 6 by 4 or 3 by 2 ampere. Similarly for 10 ohm, RL is equal to 10 ohm, IL will be IL is equal to 6 by 2 plus 10, that is 6 by 12 or 1 by 2 ampere. And for 100 ohm, if RL is equal to 100 ohm, IL is 6 by 2 plus 100, that is 6 by 102. Because this 2 is very less as compared to 100, then you can neglect, and then it will be 0.006 ampere. As you can see, when you increase the value of the load resistance, the value of the current, here this is 1.5 ampere, this is 0.5 ampere, and this is 0.006 ampere. That means it is decreases with increase in the load resistance. Thank you.